In this video, we're going to be talking about the probability of compound events. So our essential questions are, what is a compound event and how do you find the probability of a compound event? So first of all, what is a compound event? A compound event is an event that consists of two or more simple events. So if you put two simple events together, you have a compound event. So some examples of compound events would be rolling multiple dice, where rolling a single dice would be a simple event, but rolling multiple dice would be a compound event. Flipping multiple coins, combinations of outfits consisting of shirts, pants, and shoes, combinations of cards in a game of poker, spinning multiple spinners, rolling a number cube and flipping a coin, and many more. Anytime we put two simple events or more together, we have created a compound event. So how do you find the probability of a compound event? Well, the good news is you're going to find the probability the same way we found the probability of a simple event, and that is with this ratio. It's the number of favorable outcomes over the number of total possible outcomes. Now, this is critical. When it comes to a compound event, the single most important thing you can do is to find the total possible outcomes, because compound events have more outcomes typically than simple events. So finding the total possible outcomes is the most important thing. And to do that, it's finding the combinations of all those simple events, and we're going to create what's called a sample space. Now, a sample space is just a list of all the possible outcomes of an event, okay? It's nothing complex. It's just writing down all the possible outcomes of an event. So to do that, we can see all the possible outcomes, and we'll get the denominator of that ratio. So three ways that we can get a sample space would be to create a tree diagram, just make an organized list, or create a table. And I'm going to show an example of each one of those for the following compound events. So here's a scenario. A coin is flipped and a spinner like the one shown is spun. What is the probability of getting heads and blue on the spinner? So we've got two things happening here, and that's what makes it a compound event. Flipping a coin is a simple event, and spinning a spinner is a simple event. But when I do them both together, it becomes a compound event. So how many different combinations of outcomes can we have? So we can create what's called a tree diagram, where I make a space here for the first simple event and a space here for the outcomes of the second simple event. So one possible outcome of the coin would be to get heads. And then I could pair that with heads yellow, which is this outcome. I could get heads blue, which is this outcome, or I could get heads red, and that's this outcome. So there are three possible outcomes if I get heads on the coin. Now, if I get tails on the coin, I could get tails and yellow on the spinner. That's a different outcome. I could get tails and blue on the spinner, or I could get tails and red on the spinner. So that's all the possible outcomes I could have. So if you look over here on the right, this is our sample space. This is a list of all the possible outcomes of this compound event. So I have 1, 2, 3, 4, 5, 6 possible outcomes to this compound event. Now that's important to note, because that's going to give me the denominator of my ratio. So how am I going to find the probability of getting heads blue? Well, I'm going to use the sample space now. So I know the total possible outcomes is 6. There are 6 possible outcomes. Now, how many of those outcomes are favorable, or what we're looking for? So we're looking for heads on the coin and blue on the spinner. And if I look through the list here, that occurs right here. Heads on the coin, blue on the spinner. And that's the only time it occurs out of all the outcomes. So there's only one favorable outcome out of the 6. So there's our probability, 1/6, or we could write that as a percent. 16 and 2/3% is 1/6. So it's about a 1 in 6 chance of getting heads and blue when flipping the coin and spinning the spinner, or a 16 and 2/3% chance. Now that's a tree diagram. Another way we could create a sample space is just to create an organized list, and that's what I did here. So here's the situation. Students are assigned a temporary password the first time they visit the computer lab. Temporary passwords consist of a letter, either A, B, or C, followed by a number, 1 or 2, followed by a letter X, Y, or Z. How many different temporary passwords are there? And what is the probability of getting a password with a Z in it? So what I did is I created an organized list. All I did right here was list all the ways that my password could start with an A. So I could get an A, a 1, and an X, an A, a 1, and a Y, an A, a 1, and a Z, or an A, a 2, and an X, an A, a 2, and a Y, or an A, a 2, and a Z. And then I did the same thing if my password starts with a B, and then I did the same thing if my password starts with a C. So then that gives me a total of 18 outcomes. And again, that is super important to find out first. There are 18 possible outcomes. Now I'm looking for the probability of getting a code with a Z in it. So I know that there are 18 possible outcomes, and now I just look through my sample space to find how many of these outcomes have a Z in them. So I'm looking through, and it's going to be all of these here at the bottom. Because my list was nice and organized, they're all together here at the bottom. So that's 1, 2, 3, 4, 5, 6. There are 6 outcomes that have a Z in them. So my probability is 6 out of 18, which is 1/3, or a 33 and 1/3% chance of getting a password with a Z in it. Okay, so pretty repetitive. Again, the two things we're looking for are total possible outcomes and then finding the number of favorable outcomes. Once we know those two things, we can find our probability. And lastly, I'm going to make an organized table. That's another way to create a sample space. 2 dice are rolled. What is the probability of rolling greater than a 4 on either cube? So I made a table here to show all the possible outcomes. So you'll see on the left-hand side, this would be the first number cube, or the first dice. These are all the possible outcomes of the first dice: 1, 2, 3, 4, 5, or 6. And then over here, I've got the second dice, and then the same outcomes occur: 1, 2, 3, 4, 5, and 6. And then in here, I have the combinations. So I could roll a 1 and a 1, a 2 and a 1, a 3 and a 1, a 4 and a 1, and so on. So I've got all these different combinations of outcomes on these dice, and it's a 6 by 6 table, so that makes 36 possible outcomes. And I've got them all organized here. So now I want to find what's the probability I'm going to roll something with greater than 4 in it. So now I'm looking for all my outcomes that have something greater than 4. Well, the only way to get greater than 4 is to get a 5 or a 6. So this whole row is going to have a 5 as one of the outcomes, and this whole row is going to have a 6 as one of the outcomes, as well as this whole column and this whole column. So all of these outcomes that I just highlighted have one of the dice that rolled greater than 4. So now I just have to count how many that is to find my probability. So I know there's 36 possible outcomes, and then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There are 20 of those outcomes that have an outcome greater than 4. So here's my probability. And then as always, I want to simplify that fraction. That simplifies to 5/9. So my probability of getting greater than a 4 on one of the dice is 5/9, or 55 and 5/9%. And there you have it. So compound events, you have to get the sample space, and 3 ways to find the sample space: either create a tree diagram, an organized list, or a table.